Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at the mean and variance of P hat being the sample proportion. See, if I'm interested in the proportion of students who own an Xbox, my population is all students. That's heaps and heaps of people. So I'm not going to ask every single student. Instead, what I'm going to do is I'm going to ask a sample of here n students. So if I let X be the number of students who own an Xbox, the sample proportion of students who own an Xbox is just the number who own an Xbox divided by the total number of students I ask. Remember, P hat, the sample proportion, is there to give me information about P, the true proportion of every single student who owns an Xbox. So, each time we ask a student, this is a Bernoulli trial. They can either own an Xbox or not own an Xbox. Basically, we give them a score of 1 if they own an Xbox and 0 if they don't own an Xbox. So remember that if you perform heaps of independent Bernoulli trials, you get a binomial distribution. So here, X, the number of students who own an Xbox in my sample, it follows a binomial distribution. So remember, for any binomial distribution, the expected value is n times p. So n here is the number of students I asked, number of trials, and P is the true proportion of students who own an Xbox. I don't actually know P, however. And for any binomial random variable, we know its variance follows this formula here. So these two formula in black just give us rules about expectation and variance that we're going to use here. Okay, so let's come up with the expected value of the sample proportion and the variance of the sample proportion. Well, I know that the sample proportion is just x over n. X is a binomial random variable, and n is just the number of students I asked. I can rewrite this as 1 over n times x. So, using this rule here, if I have something in front of the x, the expected value is just going to be 1 on n times the expected value of x. So the expected value of x was np. Of course, the n's cancel out. I'm just left with p. So the expected value of my sample proportion is whatever the true proportion of students with an Xbox is. So I can do something similar to come up with a formula for the variance of P hat. So remember, P hat is just 1 on n times x. So using this rule down here, if we have something in front of the x and we're taking the variance, I square that, so it becomes 1 on n squared, times the variance of x. Now the variance of x is np times 1 minus p. And of course, n on n squared is just 1 on n. So the variance of my sample proportion follows this formula here. So let's now look at actually using these formula. So let's try this question here. Say I roll 2 dice at the same time, record their sum, do this 60 times, and I want to calculate the mean and standard deviation of the proportion of times that the sum is less than 4. So this sounds complicated, but it's actually really simple. Let's first calculate the probability that if I roll 2 dice at the same time, the sum is less than 4. So how many ways can this happen? Well, I could get a 1 on both rolls, I could get a 1 on the first, a 2 on the second, or the opposite, 2 on first, 1 on the second. There are 3 ways that this can occur. The total number of outcomes, so there's 6 outcomes for the first roll, 6 for the second roll. Total number of outcomes is 6 times 6, which is 36. So 1 over 12 is the true proportion of times that this will happen. If you roll 2 dice at the same time over and over and over again, infinite number of times, 1/12 of the time, you will get a sum less than 4. So this question is asking us to calculate first the expected value of P hat. So remember from the previous slide, that's just P. So here it's 1 over 12. If I perform this experiment 60 times, I expect that 1/12 of the time, I will get a sum less than 4. So for the variance of P hat, we're again using the formula we came up with on the previous slide. So P is 1 over 12, so 1 minus P is just 11 over 12, and I need to divide by n, the number of sample points, in this case 60, the number of times I performed the experiment. So putting that on my calculator, I get a variance of 0.00127. The question asked me for the standard deviation. So remember, the standard deviation is the square root of the variance. I'm not actually going to round this on your calculator. You just put square root of answer, and you should get about 0.036. So what do these numbers actually mean? Well, if I kept performing this experiment over and over again and noted the proportion of times that I got a sum less than 4. So the first time I do it, I might get, a sum of less than 4 1/12 of the time. The next time I might get 1/10 of the time. The third time I perform the experiment, I might get a sum of less than 4, 1/15 of the time, and so on. It's just saying that the mean of these values I expect to be 1/12, and the variance of all these values will be 0.00127. Standard deviation of all of these scores we expect to be 0.036. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.